330 meters of concrete and glass, 105 floors above Pyongyang. Construction starts in 1987. The hotel reaches its full height in 1992. It has never opened. No completed lobby, no working guest floors, no first check-in. At night, one side of the tower lights up with more than 100,000 LEDs. The screen works. The hotel behind it does not. The Ryugyong Hotel begins as Building 105, a hotel planned above every other building in North Korea. 3 sloped wings, 1 sharp pyramid, a 40-meter crown at the top. The tower is designed to rise 330 meters. In 1987, that would place it among the tallest buildings on Earth. The name comes from an old name for Pyongyang, Ryugyong, capital of willows. The location is central, west of the Taedong River, near broad boulevards, apartment blocks, government buildings, and the city metro. The site needs one object, large, visible from every direction. Workers survey the plot. Crews clear the ground around the future tower. The foundation begins below street level. Concrete goes down first, then reinforcement, then more concrete. A 105-floor hotel cannot sit on a shallow slab. The load moves downward through columns, walls, and a central service core. Every floor adds weight. A hotel also needs far more than a structural frame. Elevators, water pipes, kitchens, laundry rooms, air handling, fire systems, electrical risers, thousands of doors. All of it must fit inside the same vertical shaft system. In 1986, a building in Singapore had set the benchmark. The Westin Stamford opens at 226 meters, 73 floors, 1,252 rooms. It becomes the tallest hotel in the world. Its elevators run, its kitchens open, its rooms receive guests. 1 year later, Pyongyang begins a taller answer. Ryugyong is planned at 330 meters. That is 104 meters above the Singapore hotel. The floor count rises from 73 to 105. The proposed room count changes across early reports. Some plans list more than 3,000 rooms. Other figures reach 7,665. The top levels are designed for restaurants. 5 revolving restaurants appear in early descriptions. The building does not use a simple rectangular tower plan. 3 wings rise from the ground. Each wing is about 100 meters long. Each is about 18 meters wide. The wings lean inward at roughly 75 degrees. They meet at a narrow point near the top. From the street, the building looks like a single pyramid. Inside, it works more like 3 enormous reinforced concrete slabs converging around a vertical core. That geometry has a purpose. A narrow top reduces the amount of floor area carried at the highest levels. The sloped wings also create a strong visual profile without a wide rectangular roof. The structure still needs to resist wind. At 330 meters, wind pressure changes from the ground to the crown. The core takes vertical loads. The outer walls and floor plates transfer force across the 3 wings. Workers tie steel reinforcement into dense cages. Bars overlap. Joints are wired. Concrete follows. Workers set timber and steel forms around columns and walls. The shape rises 1 lift at a time. Workers pour concrete into the forms. Pumps run. Vibrators settle the mix around the rebar. Then the forms move up. The building repeats the same sequence. Reinforcement, formwork, concrete, cure, climb. A tower this high depends on repetition. 1 inaccurate floor does not stay small. A few millimeters at the base can become a larger alignment problem 300 meters above the street. Workers climb with the structure. The crane rises with them. The three wings begin to appear over Pyongyang. The lower floors are wide. The usable floor plates narrow as the walls slope inward. At the top, the tower changes shape again. A truncated cone sits above the three wings, about 40 meters wide. Plans describe 8 rotating levels inside that cone, 6 fixed levels above them. Rotating restaurant floors require more than a circular room. They need bearings, drive systems, power transfer, plumbing connections that can operate while a floor turns, fire protection that does not stop at a moving joint. A hotel kitchen on a rotating floor is not a decoration. It is a mechanical system. The elevators create another problem. A 105-floor hotel needs vertical transport working every minute. Guests rise, staff move linens, food goes up, waste goes down. Maintenance teams cross the building. The shafts must be straight. The machine rooms must be accessible. The electrical supply must remain stable. The hotel is not complete when the concrete reaches the roof. That is only the shell. In 1987, the shell is the visible part. It is also the part the city can see. Workers assemble the tower floor by floor. The crane carries rebar, formwork, tools, and concrete equipment above the surrounding blocks. The height changes the skyline first. By 1989, the World Festival of Youth and Students arrives in Pyongyang. The hotel is still under construction. Other hotels handle visitors. Ryugyong remains a concrete frame. The target moves again. A 1992 opening is linked to the 80th birthday of Kim Il-sung. The frame keeps rising. Then the resources begin to tighten. A 330-meter hotel consumes materials long after the topping out ceremony. Concrete is only the beginning. The structure needs windows across thousands of square meters, interior walls, bathroom fittings, pumps, copper cables, generators, elevators, furniture. Every hotel room needs a door that locks, a bathroom that drains, a fire alarm that works, a bed, a light switch, a water supply. 3,000 rooms multiply every missing system. In 1991, the Soviet Union dissolves. Trade arrangements change. Fuel, materials, and external support become harder to secure. The tower is already near its full height. Then construction stops. In 1992, Ryugyong reaches 330 meters, 105 floors. No windows, no interior fittings. The crane remains at the top. Workers stop climbing the tower. The concrete shell stays open to rain, wind, and temperature changes. The building becomes a fixed point in the skyline. The exterior is unfinished gray concrete. The crown is open. The window openings are empty. For 16 years, nothing changes at the facade. No glass arrives. No hotel rooms open. No elevator doors slide apart. The planned opening becomes an old date on a construction schedule. The building is visible from kilometers away. The interior is mostly invisible. That separation matters. A skyscraper can look structurally complete from the outside while still requiring years of mechanical and interior work. The structure carries the weight. The building systems make it usable. Ryugyong has the first part. The second part never arrives. By the early 1990s, Japanese reporting estimated the construction cost at about $750 million. That estimate was roughly 2% of North Korea's economic output at the time. The number is difficult to verify. The scale is clear. A single hotel tower has absorbed a sum measured against the entire national economy. The unfinished shell remains in place through the 1990s. No crew installs guest room plumbing. No crew lays carpets. No crew tests smoke extract fans. The crane at the top rusts in the weather. At street level, traffic continues around the block. Apartment towers rise elsewhere in the city. Trams pass. Pedestrians cross the boulevard. Above them, The hotel waits. The project has now split into two separate tasks. The first task is already complete. Build the 330-meter concrete form. The second task is far larger than it looks. Turn that form into a working hotel. A hotel with thousands of rooms needs an operating model, housekeeping staff, kitchen staff, security, front desk workers, maintenance teams, laundry capacity, food supply, waste collection, heating, cooling, reliable electricity. A 105-floor hotel is a small vertical city. The structure can stand empty. The hotel cannot function empty. Singapore's former Westin Stamford provides the contrast. It opens in 1986 with 73 floors and 1,252 rooms. The building connects to a convention center, retail space, roads, public transit, and an existing visitor economy. Ryugyong is designed at 105 floors. Its proposed room capacity is at least twice as large. The concrete frame rises. The operating systems do not. By 2008, the shell has stood unfinished for 16 years. Then, activity returns. An Egyptian company, Orascom Group, enters a telecommunications and construction agreement in North Korea. Work begins around the tower again. The goal is visible from the street. Cover the concrete. Workers return to the exterior. New equipment rises along the sloped walls. Glass panels arrive. Metal framing follows. Workers fasten the cladding across the three wings. Gray concrete begins to disappear behind reflective glass. The change is fast compared with the original construction. From 2008 to 2011, the facade is covered. The pyramid becomes blue-gray in daylight. At sunset, it reflects the city and sky. The old crane disappears from the crown. The tower looks finished from a distance. The hotel is still unfinished. A facade is not a hotel opening. Glass panels control weather exposure. They improve the exterior appearance. They do not install elevators. They do not fill rooms. They do not connect thousands of sinks, showers, and toilets. The 2011 work changes the tower's skin. It does not complete the inside. A projected opening is announced for 2012. The date aligns with the centenary of Kim Il-sung's birth. The date passes. Another partial opening is discussed for 2013. That date passes too. No public hotel operation begins. No booking system appears. No guest photographs come from completed rooms. The tower continues to stand over the city. Now it has glass. It still has no guests. In 2018, the building receives a new use. One side becomes a massive LED display. More than 100,000 lights are installed across the facade. At night, the upper floors become a screen. Images, dates, patterns, and state messages move across the glass. The display is visible across central Pyongyang. The facade operates as an electronic surface for several hours at night. Behind it, the building remains incomplete. The contrast is mechanical. LED modules need wiring, controllers, power distribution, weatherproof mounting, maintenance access. A hotel needs all of that, plus the systems behind every door. The tower receives the first system. The second remains unfinished. Workers install the outer surface. The guest floors remain closed. The building is now almost 40 years old. Its concrete frame dates to the late 1980s and early 1990s. Its glass facade dates mostly from 2008 to 2011. Its planned hotel operation has no confirmed opening date. The gap between those dates creates a different engineering problem. Materials age at different speeds. Concrete can remain in service for decades when protected and maintained. Water intrusion, cracking, corrosion, and freeze-thaw cycles can change that condition. Glazing systems age. Sealants dry out. Gaskets degrade. Electrical systems become obsolete. A building left unfinished for 16 years does not restart at the point where crews stopped. It needs inspection first. Every floor needs to be checked, every shaft, every stairwell, every structural connection exposed to weather. A modern hotel also needs systems that meet current operating requirements: fire detection, emergency lighting, sprinklers, ventilation, backup power, communications, security, water pressure zones. At 330 meters, water cannot simply travel from one pipe at ground level to every bathroom above it. The system needs pressure control. Pumps push water upward. Tanks store it at intermediate levels. Valves divide the building into zones. The higher the floor, the more carefully the pressure must be managed. The same applies to fire protection. A sprinkler system needs water flow at the highest floor. Stairwells need protected routes. Elevators need emergency procedures. Smoke must be controlled inside a pyramid-shaped tower with 3 long wings. Every one of those systems has to be installed, tested, and maintained. The cost is difficult to calculate from outside the country. The internal condition is not publicly documented in full. The basic requirement is visible. A 105-floor hotel cannot open with only a finished facade. The building's silhouette hides its unfinished state. That silhouette is unusually efficient. 3 straight lines rise from the ground to a single point. The geometry stays readable from almost every angle. It looks complete, even when the interior is not. That may be why the 2008 cladding work changes the project's image so quickly. Before the glass, Ryugyong is a raw concrete shell. After the glass, it becomes a reflective pyramid. The structure remains the same. The function does not. No train brings hotel passengers to a check-in hall. No luggage carts move through a completed lobby. No restaurant floor turns above the city. The design still contains the outline of all those operations. The 3 wings still converge at the crown. The 105 floors still stand. The room count still exists only in old project descriptions. In 2025, reports still describe the hotel as unfinished and empty. Nearly 4 decades have passed since construction began. The initial construction period lasts about 5 years. The pause lasts 16 years. The new exterior work takes about 3 years. The building has spent far longer unfinished than it spent under original construction. That timeline is visible in layers. 1987 to 1992, reinforced concrete. 1992 to 2008, open shell. 2008 to 2011, glass and metal exterior. 2018 onward, LED facade displays. The hotel operation remains missing from every phase. The city has changed around it. New apartment towers appear in Pyongyang. Roads are resurfaced. Other buildings receive light displays. Ryugyong remains the tallest building in the country. 330 meters, 105 floors. A hotel designed to contain thousands of rooms. No guest has occupied one. The tower has no public room rate, no published check-in date, no confirmed opening schedule. At night, the facade shows a working image. In daylight, the pyramid reflects the sky. Inside, the work remains incomplete. 330 meters, 105 floors. Construction begins in 1987. The concrete structure stops in 1992. The facade finishes in 2011. No hotel has opened. Subscribe for more engineering stories.